Well, hello. Right now, I just want to present a quick question regarding the expansion of the universe and how dark energy is supposed to play a role in that. So, my question for someone who's a lot more um, intelligent than I am, when you have light that is traveling through space and the universe expands, you have a singular photon, and that photon has energy that's associated with it. And if I remember correctly, it would be Planck's constant multiplied by the wavelength. So as the universe expands, or I should really word that is if you have an object that is coming towards you, those photons that are coming towards you have been blue shifted, and so they are, in a sense, they have higher energy technically, and I would presume that they're getting that extra energy from the actual movement of the object that they're coming from. And when an object moves away from you, uh, the light that is coming off of it is redshifted, and so you see that as a lower frequency, and it has less energy to you as an observer. So my question is, as the universe expands, the light that is within that universe becomes redshifted. That's how, at least, I was taught, is that the light becomes redshifted as the universe expands. Where where does that energy go? So when you have that photon that is going through space and the universe expands while that photon is traveling through space, where does the energy from that photon go? Does that make sense? Because that photon will then have a longer wavelength, and that longer wavelength means that it has less energy. So as the universe grows, the photons that are flowing within the universe lose a little bit of their energy. And I guess I'm just having a hard time understanding how you could have conservation of energy if your individual photons are losing energy. Now, is it that as the photons lose energy or as they're spread out, does a photon technically break apart into smaller photon? Do you see my struggle right here? Is it that there are different levels of photonness? And I really can't explain this very well. Just know that I guess my question is, does that where does the energy go? Is it being conserved in some other way? Is it being transferred to objects around it? Because I could imagine as the universe expands, you have two objects, and if they're pushed further apart, then would that extra potential energy of pushing them apart, is that coming from the photons that are in between it? And if that's the case, are photons actually driving the dark energy? If the photons are pushing, basically, uh, I guess this is my model that's sort of coming into my head right now, is if these photons are flowing through space, are they able to lose some of their energy, lower their wavelength, and then can they push that energy in the space around it? And by pushing that energy into the space around it, could that expand the universe? That's sort of the model that I'm sort of coming up with right now, and that uh, photons, they're like little jiggles in the space-time. They're electromagnetic waves, and within them, they have energy within them. And you could sort of view them like springs, right? So there's springs that are messing with space-time. And then one could, I guess, make the argument that that process of having a electric field and a magnetic field oscillating, that in of itself might be subject to um, its own version of drag or its own version of uh, friction, if you can view it that way. And over time, maybe light is able to, it loses some of its energy. And where does that energy go? Well, it's too small to go into a new light particle, but does it impart its energy to space-time itself? And if it imparts its energy to space-time itself, would that cause an expansion of space? I mean, this is would that happen? Um, if if you know or if you have any idea, you can just leave that down. I just wanted to get this video out because because I'm interested in it. So, thank you for watching.